Hi everyone, we are going to work on some factoring. So by the end of this, now not this video necessarily, but the entire lesson, so including when you see me, you're going to be able to factor using the four methods we'll talk about. Before we start the video, please make sure that you have something to write with, a notebook, and if you want a calculator for calculations, that would also be helpful. So terms of polynomials, we have to remember this first. And this is because this is how we determine the way that we're going to factor. So on the left, this has two terms because we're separating by a addition or subtraction sign. So there are two terms here, b squared and negative 3b. In the next example, that would be three terms because again, 1, 2, 3, there are two symbols separating them. And in the last one, you guessed it, four terms because they're all separated by the addition signs. Perfect. That can be reduced into three terms, just throwing it out there, but for now we're going to go with just four terms as a quick example. So the reason I just went over all that is because when you're factoring, you have to make decisions based on how many terms there are. First thing you're always going to do is check for the greatest common factor. That's always the first step. From there, depending on if there are two terms, three terms, or four terms, you're going to use one of the four methods listed. Now, there's difference of perfect squares. Then we have the product sum method, the AC method, and factor by grouping. I'm going to upload this file to the Teams account in the general files, so you'll have access to it. But I'm going to go over each of these now. So if I'm following that chart, the first thing I always check for is greatest common factor. And here's how you do that. So you look at each term separately. So we have the 3, the 3x squared, the 21x, and the 18. I'm going to check for all the coefficients, and I'm going to check for all the variables. So coefficients are 3, 21, and 18. All of those have the greatest common factor of 3. So I write that to the side. I then check my variables. I have x squared, x, and no variable. Because I don't have a variable here, I don't have a common factor because there isn't an x in everything. So it's just the 3. So then I put some parentheses out. Now I factor that 3 out of each term. So 3x squared, if I factor a 3 out, leaves me with x squared. I'm essentially dividing each of these by that 3. The plus stays. 21 divided by 3 is 7. The x is still there. And then minus 18 divided by 3 is 6, and there's no x on that one. So that would be how you factor using the greatest common factor. Difference of perfect squares. So again, we always first check for a greatest common factor. 9 and 25 do not have any factors in common, and k squared, there's nothing else. So now, because there are two terms here, I know to use the difference of perfect squares. So I'm going to do the following. It will always look like this. The perfect square of the first term will go in the first two blanks of each parentheses. So what's the square root of 9? 3. And what's the square root of k squared? K. Sometimes it's going to be the variable repeated. It can depend. In this case, we had a coefficient. Now, the 25, what's the square root? 5. And that's how you factor with difference of perfect squares. That one usually is one that people catch on to pretty quickly because it's a nice simple pattern. Excuse me. The next method is factor by grouping. So I have the instructions from the chart written on the right just so that we can kind of go through step by step. Because I have four terms, I know that I'm choosing this method. Divide the polynomial into two groups. So I like to make a little squiggle. They have the red line in their instructions. Factor the GCF out of each half. So on the left side here, 6 and 24 have a greatest common factor of 6, and x to the fourth and x to the third have the greatest common factor of x to the third. So basically the highest exponent. Now 6 divided by 6 is 1. X to the fourth divided by x to the third is x. So I factored the 6x to the third out of the 6x to the fourth. Minus 24 divided by 6 is 4, and the x cubed, they reduce down to 1. They cancel each other out. So that's done. Now, this symbol is going to come down with me. So there's the negative. Now, 5 and 20 have a 5 in common. There isn't an x in both terms, so I can't bring that down. So now this is going to be x. Now be careful because you have the negative out here. that's going to turn this positive into a negative because you're factoring it out. So if you're factoring out a -5, that's changing that positive. This should always happen. You should always have matching numbers here. That is a big sign that you did it right. From there, you factor out the common binomial. So it's kind of the same thing. They both have that matching x minus 4, so we can write that first. And then we have the 6x cubed minus 5. And that's how you factor by grouping. Your product sum method. Now I'm going to pause here real quick. You should be taking notes as you go, hopefully that you are, and write notes to yourself. You don't have to write down like all of these because you're going to have these in a file. That's not required for you to do. These are your notes, so do what you need to make it helpful for you. Okay, so in this case, we're going to do the product sum method. So the product sum method is when we have no coefficient in front of the x squared. And you might be like, well, Ms. Ozier, there's a coefficient right there. It's the 6. I want to remind you, you always check for a GCF first. So 6, 42, and 48, they have a GCF of 6. That's the greatest common factor. So then if I factor that out, I am left with n squared minus 7n minus 8. Now this 6 is not going to be forgotten, but we're going to just factor this part now. So n squared minus 7n minus 8. And this is where, so again, the 6 is just going to kind of come along for the ride. But this is where you just do your 2 pairs of open brackets. Because that n is by itself, the n is going to repeat in both. And then now is where 1, 2, and 3 are coming in. If both integers are positive, well, that's not the case. If both integers are negative, C is positive and B is negative. So that means we're going to have a plus and a minus. And it doesn't matter which way you put it. Okay? So now, the only other thing is you have to just pay attention to if it's negative and positive, that means that they would both be negative. All right. The reason this is called the product sum method is because you want to find two things that add to the product of 8. So they have to have a product of 8 and they have to add to -7. So -1 and 8, or -8 and 1. 2 and 4 where 1's negative, or 2 and 4 where the -4 is negative. I'm hoping that you're remembering seeing charts like this. So in order to get -7, I need this one because -8 plus 1 is going to give me the 7. So that's how I work through one like that. Again, you guys probably got pretty good at this last year because this is one that has a decent pattern. The last one is AC factoring. Now this one is the more challenging one, but again, once you understand the procedure, you can definitely do it. The reason that we have to do this one is because you don't have a greatest common factor. So 3, 34, and 40 do not all have a greatest common factor. And that 3 in front of the x makes it so that we can't use the product sum method. So we use what's called AC. And the reason it's called AC is because you multiply the A, the first term, the coefficient of the first term, so 3 in this case, by C, which is the constant. Because all quadratics are in this standard form, where these relate to the coefficients of the variables. Okay, so 3 times 40, that would be at 120. Now we're going to have to do a little bit of, guess and check work to figure out what's going to add to 34. So I'm going to use the same method as we just did in the product sum. I need to find things that are going to add to 34 that multiply to 120. So 12 and 10 are the first two that come to mind. And that didn't work. So now I'm just guessing. I just did 8 and 15. That doesn't work. Looks like I need to go a little bit higher. So 120 divided by 20 is 6. And I'm just guessing and checking my way through this right now. Let's do 3, 40, and 3. So that tells me it's somewhere between those two. Let's do 4. 120 divided by 4 is 30. So there it is, 30 and 4. Now some of you are like, of course it wasn't. Ms. Ozier, 3 times 4 is 12. I know, but I just kind of wanted to show the process of guess and check. So we use that to do this next step. So we're going to rewrite this as 3x squared, and I break my 34 into the two numbers that I just found. It technically doesn't matter which order you write them in, but I'm going to tell you why I chose to put them in that order. My next step is to factor by grouping, which is what we did a couple slides ago, where I split it in half and I go from there. Because I know that the 3 and 30 are going to work really nicely together for a greatest common factor, that's why I put the 30 first and the 4 second. It doesn't matter, it'll still work out to the same answer. I just try to make my life easier when I can. So I'm now going to factor out the 3x from these two terms, and that's going to leave me with x plus 10. I bring that plus sign down. I factor out the 4 from the 4 and 40, and again I'm left with x plus 10, and that's what I should have. So then again, x plus 10 is what's repeating, and the 3x plus 4 is the other part of that. So that would be my final answer of factoring. This one takes a little bit longer. It's okay if you're confused right now, but those are the steps to do AC factoring. At this point, if you watch the video and taken notes and you're feeling a little bit overwhelmed, it is 100% okay to stop and move on, and I'll see you the next time in class. However, if you want to kind of work through these and see what you can do, I recommend that right now you pause the video, you use your notes to try to figure out how to do each of these, and then in a moment you can play it again, and I'm going to go over them. So if you would like to do that, take this opportunity now to pause the video and try these problems. In about 3 seconds, I'm going to go over them. All right, so in the first example, I see that I have two terms and I do not have a greatest common factor. So that means I'm just going to do difference of perfect squares. So that's just going to be v plus 8, v minus 8, because I'm using that method. In the example over here, I have a leading coefficient of 1, so there's definitely not a greatest common factor. Because I have a positive and a negative, two negatives multiply to make a positive. So I'm going to use two negatives because this 7 needs to be negative. Factors of 10 that I can think of really quick are 2 and 5, and they definitely work to give me 7. So I'm done. On the bottom left, I don't have a greatest common factor, and I have a coefficient in front of the squared variable. So I'm going to do the AC method. So 5 times negative 30 is negative 150. And then I'm going to have to work through that to find factors that are going to add to negative 19. So 150 divided by 5 is 30 and 5. And one of those is going to have to be negative in order to make it a negative 150. No matter which way I do it, they're not going to subtract to be it. So I'm just going to kind of rule that one out. So I'm going to try another one. 150 divided by 15. That's 10. 15 and 10 still not going to give me the 19. 150 divided by 8. Why not? I'm just trying. That doesn't work at all. 150 divided by 9 doesn't work. 150 divided by 12 doesn't work. I'm just trying all sorts of numbers. And I already did 15. Divided by 6 is 25. So there are my numbers, 6 and 25. And again, I was just guessing and checking. I got a lot of decimals, and those ones didn't work. Now, 6 and 25, you might be thinking, Miss Osier, that's 31. I know, but remember, it was a negative 150. So that means one of these has to be negative. I chose the negative 25 because of the negative 19. So now I'm going to use these two. I'm going to place the 25 next to the 5n to make my life easier, and the 6n with the 30. I'm going to change colors just to make it a little bit easier to see. So I'm going to GCF the left side. Oh, just 5n, not 5n squared. And I have n minus 5 left. The positive comes down. The 6 and the 30 have a 6 in common. So again, I have n minus 5. The n minus 5 matches. And I have 5n plus 6 left. Moving on to the last one. It has 4 terms, so it's factor by grouping. 3x squared and 6x have a 3x in common, and then I have x plus 2 left. 4x and 8x have a positive 4 in common, and then again x plus 2. That's a good sign. It means I did it right. And then I just write my final answer. So I hope that went well for you. If you chose to keep watching the video, I will see you in class. I hope you have a great day.